Okay, so here we are with the meat and potatoes of this program. It's this 3D embossed carving of the tiger. What we're going to do here is basically, we don't need all these straight lines over here. Okay, you see all these straight lines? We only want the 3D information from the tiger. Alright, so let me throw on a little bit of music from my acoustic days. Let's talk about this a little bit, because here's the thing. This is going to be cut with a 1/8" ball mill, and it's going to run all these lines. It's going to scan across there like that. Alright, now you'll notice it's cutting a lot of straight areas. We don't need all those straight areas because we're going to cut with a 1/4" end mill, a flat mill anyway, all the way around this thing, right? So it doesn't make sense to cut those straight areas with a ball tool, an 1/8" ball tool, because you're going to wind up with a whole bunch of little cusps, and it's not going to cut a perfectly flat surface anyway. So this is a particularly interesting challenge, to remove all this information from the toolpath, because there's, you know, like 1,000 lines of code that we don't need in this toolpath. Okay, you can see all the straight areas, all of these lines that scan across. All right, that's just how the program spits out the code. And now we could go ahead and eliminate all of these lines, but if I zoom in here, you'll see that all the little lines are connected, okay, because of the way it scans across. And then we'd have to reconnect them over here along the contour of this 3D relief. So this is a particularly challenging thing to take out all of this extra stuff, right? We need another program to do that, and I'll show you how to do it. It's not easy, so pay close attention. Okay, so the first thing that we're going to need is this program right here from Scorchworks. It's called G-Code Ripper. This is a free program. It's great. Basically, what I'm going to do here with this is I'm going to convert my G-code into a DXF. So I'm taking machine language and I'm going to turn that back into geometry. Alright, there's a lot of things you could do with this program. You can simply alter your scale for your G-code. Scale in the XY, scale in the Z. You could scale your feed. You could rotate it, stuff like that, and then repost the code. You can split it. If you need to split your G-code into a smaller file, okay, which is a handy thing if you have a machine like mine, where you can actually download the program but you don't have that much space to download it. You can make the file smaller and then run it in 2 sections, because the machine runs smoother when it's got the program downloaded into it. Alright, and this is your parameters for splitting and so forth. Now this is kind of interesting. You can wrap the program, so if you have a 4th axis, you can wrap the program around a circular object. Okay, it's got a probing function in here, which I haven't used. But I see it'll show you touch off points for probing and so forth. And then this is what I use it for most of the time, is to just convert my G-code into a DXF file. So all you got to do is set this up. I set not to include any rapid motions, but it will export them on a separate layer for you if you do include it. But that's it. I'll just go ahead and export this file and bring it into the next program. Okay, so save that as a DXF and then use it in, and then open it in this program right here, DoubleCAD. This is another free program, and it's very similar to AutoCAD. Now this program here, DoubleCAD, is very useful. Okay, for one, it works with DXF files very, very well, and it will output them in a number of different DXF years that AutoCAD has revised the DXF standard throughout the years. So you can, if you have a DXF from just about any year, it'll be compatible with this program, which is a nice thing. The only hitch with all the other programs are like 100% free. You could just download them and use them right away. This one, you got to send them an email. They'll email you back with a link to go ahead and download the program. And when you fire the program, there's an initial splash screen that pops up, and you just one step through that and then close it, and you're done. Then you can use the program. It's really no hassles. There's no pop-ups, nothing like that, and I have not gotten a single email from these people since. So there's no spam. It works great, and I use it quite often. It's a great free program from TurboCAD. This one's called DoubleCAD. They offer this to the public for free as an incentive to get you to buy, obviously, their more expensive software. But this program, believe me, it works great. So basically, we have turned our tool. We're looking at our tool path here. We've turned this into now geometry. Okay, not machine language anymore. This is now geometric. Okay. So what we're going to do, the reason why I like to use this program is because it allows you to select things like the way AutoCAD would select them. If you use your selector in this manner, drag to the right, you're going to just select anything within the box. If you drag to the left, you're going to select everything that the box touches. Okay, you see, I didn't draw a box around all of that, but it selected all of that, and that's exactly the feature that I like about this. If you drag it the other way, you got to go all the way around, so anything within the box then is selected, see? But this way, you only got to touch it, and it selects everything. Okay, so what I'm basically wanting to do here is remove all of the information from this file that I don't need. Okay, because the only thing we want to keep is the 3D stuff. We want to take away all these straight lines. Okay, so let me go ahead and set it for this view. And all I'm going to do is drag select, just so I'm touching that edge right there. And it's going to select all of that. You see that? You see how it selected everything? Okay? And I just hit delete. Boom. You're done. It's like a very simple process. And down here the other way, select all that stuff. Boom. Deleted. So now I have basically all my 3D information here. Only. This is all I want, is the 3D information only. Okay? So, yeah. I mean, that's like a game changer right there, because if you wanted to take all that stuff out of the code, it would be a real pain in the butt. I mean, you'd be at that all day long. Okay? And then trying to recode it. Now, the problem we're going to run into, though, is, like as I mentioned before, these lines are not connected to go in a zigzag pattern. Okay, so we're going to have to write another toolpath for this, which I'll show you how to do. Okay, but pay attention to this, because this is a little tricky. This is the fast and easiest way that I have come up with to do this. So unless you're using software that you're paying for, very expensive software, by the way, that you pay for, you are not going to find an easier way to do this. Okay, this is a tricky thing to do, but it can be easily done. See, I've automated this process for the most part by eliminating all of that extra stuff that we don't need. So basically, I'm just going to save this file as a DXF and then bring it into Cam. Okay, so here we are in CamBam. I have now brought the edited file into CamBam. Notice it doesn't have all those extra lines around it. Now if you take a look at CamBam on this layer, you'll see all these lines. Okay, there's like a whole mess load of these little lines. And the problem is with CamBam is it's going to take a long time to process all of these lines. Okay, so what we need to do with CamBam is take all of this and convert it to polylines. Okay, but let me tell you something. It'll show you right here how many lines you got. There's 21,041 lines here. Okay, each one of these little teeny, I don't know if I zoom in here, as you may not even be able to see how small they are. They're really teeny tiny lines. They're very, very small. Alright, and I can show you how this plays out three-dimensionally as well by just shifting it over. So the challenge here is, first of all, you need an ultra-fast computer to do this, okay, because this is going to take you all day. But if you do it one little section at a time, you're going to be way happier with that result. So the procedure for doing this is a little tricky. Let me show you how you do it. I'm going to go and fit that to the screen in this orientation. What I want to do is basically do another layer, create a new layer. Okay, so I'm going to select a small chunk of this at a time. Alright, like let's say just this section right here. Okay, and I'm going to go cut. Okay, and then I'm just going to go paste it to my new layer. Now I'll shut off the other layer. I'll hide it. Okay, so we're only looking at this one little section at a time. Now, as you know, there's a million little lines in this layer. Okay, as you can see. And notice they are scanning the way, they are orientated the way it would zigzag across, and that's important. Okay, because that's the way we wrote the toolpath, and they're still conforming to the way we wrote the toolpath. So that's absolutely what we want. All right. So basically, I'm going to select all of these, and I'm going to right-click and go Convert to Polylines. Now you see that took fairly quickly, and now I'm going to go Polylines Join. And you can join this at whatever tolerance you want. I mean, you could join it at 0 if you'd like, but I'm not too concerned about it, so I'm going to join them at 1/1000 of an inch. Okay, press enter, and now you will see they are all polylines. See, if I step through the list on that layer, they've all been joined. Okay, and this is important that you do this. So now watch, I'm going to hide this layer, I'm going to unhide, or I'm going to show the other layer. Okay, and then I'm going to select another little selection at a time. I'm going to select this selection, I'm going to just go cut. Okay. Yeah, there's so many little lines, it takes a while to process this, okay? So I'm going to hide this layer. I'm going to show my active layer. And I'm going to paste them there. Now while they're still selected, I'm going to go polylines, convert to polylines. Alright? And then polylines, join. Say OK. Okay? So I'm just going to do this a few times, a section at a time, until I get the whole thing converted to polylines and joined. Alright? As you can see, it's taking a little bit longer there to process. If I had selected this whole entire thing, I may even get an error because it takes up so much memory and so much processing power to do that. That's why I'm only doing it one little section at a time and keeping track of what I'm doing by putting those, there it's finished, by putting those on another layer. Okay, so I'll show the other layer where I got all the lines. I'll hide this layer again, and then I'm going to go and take another little selection at a time. Okay, I'll just select that part right there, cut it, and there's so many lines on this thing. And I will just go ahead and paste that. The parent layer is not visible. Would you like to make it visible? Yes. Okay, so I'm going to hide the other layer. Well, actually I have that selected now, so I'll just go convert to polylines. And polylines join. Alright. Now believe me, doing it this way is going to be a whole lot quicker than if you selected this whole thing. Alright? This is really going to frustrate your day if you try to do something like that, because you need a super duper fast computer to do this. Okay, you can see how long it's taken over here. And this is a fairly quick computer actually. So yeah, so that's the process, and we're going to process all of this in the same manner and put them all on another layer and join all those polylines together. Yeah, it's taken its time to do this. Okay, it's just this is the issue that you run into with doing these type of relief carvings. There's no way around it. I have experimented with a lot of different ways to do this, and you get up against this wall, and it's very frustrating, but that's just the nature of the beast. You know, it takes some time to do this, so just gonna cut that, show my layer, paste it there, polylines, convert to polylines, polylines, join. See, the smaller section I choose, the quicker the processing time it is. And if you break this up into a few different cuts like I'm doing right here, it's really gonna go fairly quickly, actually. So hide that again. So it makes it easy. I'm just turning on and off the layers just to make it easier for me to make a selection over here. That's basically the only reason for that. Alright, so I cut that, and show the layer, paste it, polylines, convert to polylines, wait for it, polylines, join, wait even more for it, and you know, it's just a little bit of a waiting game. But the thing is, if you wanted to, let me tell you something. You could write a toolpath for this right now. There's a tricky way which I'm going to show you how to do that, because you want to trick this system into thinking something the way you want it to do. We'll get to that in a minute. But the thing is, if you took all these little lines and just went ahead and directly started an engraving program on it, it would take a fairly long amount of time to write a toolpath for that, even though it's just following the lines. Alright, the engraving toolpath is like the simplest toolpath there is. It's just going to follow your geometry, and that's it. Alright, so I think we come pretty close to the end of this ordeal here. It wasn't too painful. Just a little bit of a waiting game here. I don't like the way that's selected. There. So, cut. Show my layer. Paste it. Polylines. Convert to polylines. Polylines. Join. Okay. And once you put that joining tolerance in, obviously it's staying within the system. I think 1/1000th of an inch is fine for cutting wood. You know, obviously if you're cutting metal, you may want a higher joining tolerance, but the program was written with a tolerance of about 1/1000th of an inch to begin with anyway, so I don't think it matters too much. So I'll just go ahead and select this last little selection, cut it, show my layer, paste it, polylines, convert to polylines, and polylines, join. Alright. So you wait for the processing to happen. But like I said, if you try to write a toolpath just on those lines, you can do it, but I'll tell you one thing, you're going to get very unpredictable results. Number one, that's the major problem. It's not that it's a problem that it's going to take you so long to write the toolpath. Okay, writing the toolpath won't take you as long, but once these are converted to polylines, writing the toolpath is almost instantaneous. Okay, so once this is done, we're going to save the file, and this time I'll save it to a CAN-BAM file because I want to retain my toolpath information within the file. Okay, so we're going from a DXF to a CAN-BAM file because we're going to add toolpath information to it. Alright, so that's important to remember. But yeah, once these are converted to polylines, you will get predictable results. Alright, number one, that's the most important thing, because like if you try to write a toolpath on a bunch of little 21,000 lines like that, you're not going to get predictable results. You're going to have rapid motions going all over the place. And now I don't have anything on that layer. It's done computing. I don't have anything on this layer anymore. All the information is on my new layer, and it's all been converted to polylines. So let me zoom out to fit. Zoom to fit, and you will see. Let's just take an isometric view of this. So we'll just view it like that for a minute, and all the information, and now I could just run through with my arrow button through the list of those polylines. As you can see, there's a lot fewer entities because they've all been converted to polylines. Okay, and I'm just pressing the arrow key to step through all of that. So that's the manner in which we want to scan the tool path. Okay, and you'll see when I'm going to save this now as a Kanban file. Alright, so basically I have brought in the Kanban file. This is basically exactly the same thing what we did, but I didn't save it as a DXF. It contains all the DXF geometry that we just saved as polylines. The only difference is this is a Kanban file, alright? And here's all of our polylines. Alright, as you can see, we got a ton of polylines. Alright, but it's not like having a million teeny tiny lines. Okay, so we're going to get predictable results when we run an engraving program on this. That's the key thing. We want predictable results. We don't want, you know, a bunch of nonsense. So basically, here's how you do it. You're going to select everything. Alright, here, I'll just go ahead and, I already wrote an engraving program, but I'll delete it. So we'll write another one. So, you select everything. You go, I just hit it, you can hit it over here, or you can go Cam, Engrave over here. Either way, doesn't matter. It's going to bring up the same menu over here on the left. And let me show you the menu I'm talking about here. Alright? So I'm into this menu right here, which will give me our parameters. A tool diameter, we don't need, we know we're going to run this with an 1/8 inch ball mill. So, I mean, it doesn't matter. It's just an engraving program. But I'll put it there anyway. So I'll put a 0.125. And by the way, this system has no way to tell it whether it's going to be a ball tool, whether it's going to be an end mill, whether it's going to be a V cutter, or any type of profile information for the tool itself at all. So I can put a tool diameter in it. It doesn't matter. An engraving program is going to run on the line with the center of the tool on the line no matter what you do. So the only reason why I'm putting tool information into this program, and I'm going to number it, I'm going to put a tool number on it. So when I output the code, when we bring it into for verification purposes, it'll make our lives a little bit easier. Alright, because we'll have to have tool information in the Camotics program just to let the program know what kind of tool we're going to use to cut it with. Okay, but at this point, it really doesn't matter. You might want to make a note in your G code what tool you're using. Just put it in parentheses over there, and that way when you step through the code at the beginning of your tool path before you actually run it on the machine, just to make sure, just as a quick sanity check, I like to do it just so I know what tool I'm going to use. So now the parameters. Okay, I have the depth relative to geometry. I don't think it matters, but yeah, I'm leaving it there. I got my cut feed rate for 60 inches per minute and my plunge for 20. Now here's the trick of this. The clearance plane. Normally I would set my clearance to be over the part. Okay, I want it to be, I usually set it to like 0.1 of an inch over the part. Alright, but here we're going to set our clearance to our floor depth, which is, as we know, minus 0.4 of an inch. Okay, that's the deepest cut that this thing is going to make. And the reason for that is we're tricking this system into doing what I want it to do. If we set a clearance plane at normally what I would set it is above my part, like 0.1 of an inch, so it clears. If we set it, now keep in mind, we're not going to run the toolpath like this. We're only doing this for the strict purposes of tricking it into doing what I want it to do, which is we're going to connect all these little lines on the perimeter of this thing, okay? And they will be connected in a certain fashion, in an organized fashion. That is critical. We have to do that, all right? And the toolpath itself is going to do that, okay? Because when we're done writing this toolpath, we're going to, well, you'll see how it's going to fix, how we're going to fix that next, okay? So we're tricking the system into doing what we want it to do, all right? So basically, you set your clearance plane for your depth of floor now, all right? And then we'll go and modify the code, and it's really easy to do that. It's a pretty automated process. We'll just find and replace those files in NC Correct. We'll just find and replace those rapid motions in NC Corrector, and we'll be able to do that very quickly. All right. So basically, that's all you need to do. This roughing clearance says nothing. It doesn't do anything. That's the only parameter really that we're interested in, is this clearance plane. All right. Like I said, the tool diameter doesn't matter. It only matters for when you want to go ahead and verify it in Camatics. Then it's going to make a little bit of a difference there. But we can adjust that as well. That's not a big deal. It's just a T2 or T3 or T1, 2, 3, whatever you want it, and then an M6. All right, to tell the thing to do what you want it to do. This I have set to geometry. That's the cutting depth relative to the geometry. This does make a little bit of a difference, I think. So I'm going to leave it there. You can play around with it and put it on absolute. I think it really doesn't make a difference whether it's on absolute or not. And it won't make a difference anyway, so it's kind of irrelevant. But I'm going to generate the toolpath and see how fast that took. That was like instantaneous. Boom. It's like done. Because we converted out all of these lines to polylines. Okay? And when the system, this system likes polylines for some reason. So when you have done that work ahead of time, the toolpath creation is instantaneous. You could save that G-code file and it's going to be like snapping your finger. It's like that. It's actually like that fast. Okay, so that's the benefit of doing that. So now we fixed this. So now I'm going to show you what the toolpath looks like in NC. Okay, so here we are back again in NC Corrector, and we're looking at our toolpath. Alright, now you'll notice right off the bat that that thing is going to drop a rapid motion right on the floor of that part. Okay, let me show the bound box for it. Our Z is -4, but the top of the Z is 0. Okay, we don't have that extra clearance which I normally put in at 0.1 of an inch. Alright, so if I step through this program, you'll see our initial motion is going to take us right down to the floor, right there, and then it's going to wrap it across all the way down at that level of -4 of an inch. Alright, and then it's going to start the toolpath. But notice, we have the toolpath is doing exactly what I want it to do. Alright, which is a beautiful thing. Alright, now if you follow this step by step, you're going to get these results. If you wanted to create a toolpath on all those millions of lines, you're going to get rapid motions all over the place. It's going to go from one area of the part to the next. It's not going to scan directly across the part like it is nice and smoothly now. This is what we want. We want it to scan across this part in an orderly manner. All right. That's why we took those steps to get to this point. All right. And I'll just fast forward it all the way to show you. And I can go ahead and show you in this way too. It's going, and trust me, I've looked at this before, so it's going exactly, doing exactly what I want it to do. And notice, see, now we have the little lines that we wanted. This is the key feature that we wanted here. Okay, we want these little lines here, and they're all going to be G00 rapid motions, but that's not a problem with this program, NC Corrector. Let me show you how quickly we're going to be able to fix that. I'm just going to go right here to edit, and I'm going to go replace. Now here, I'm just going to replace everything with a G00, okay, to a G01. I'm going to say replace all. Boom! You see that in action right there? Look at the action that's taking place right there. It's replacing all of those rapid motions to feed rate. Just like that. It's automatic. 280 match found and replaced. Done. You see that? Isn't that like the most, I mean, that's beautiful. And I just go File, Save, and we're done. See that? So that's awesome. And so now, if I go ahead and step this back, it'll refresh my data. Refresh that, and you'll see on the screen everything is good. See that? The only problem we have is with these two lines. Okay, we got this one line that's this one line right here that's coming right down into the part, as you can see. So that's not a problem, because all we're going to do is just edit the code. I mean, it's like this is as easy as it gets. We'll go to that line. It's like one of the first lines in this code, right there. Okay, that's going to go to a Z -4. So I just want to set that to a Z.1, so it jumps up to my clearance, and we'll change it to a rapid motion from a G01 to a G00. All right. And then see there, we fixed that. And then the next line is that's set to a feed rate. I'm gonna set that to, I'm gonna leave that on or set it to a rapid. Okay, so that's gonna wrap it over to that position, and then we're gonna get into our plunge. All right, and I can give that an F20 command for feed rate 20, and after that I want this thing to feed at 60, so I'm gonna go F60. There we have it. Now it's gonna feed from that point on and start the tool path. Okay, so this is just gonna be my normal feed rate. That's it. You know, the last line of code is going to be right there. Okay, right there, and then the program's going to stop. At this point, you know, you could add another line of code to have it wrap it up to your clearance, so we can do that, no problem. So it's just a G00, Z 0.1. Okay, And that's it. So there you have it. We've added a little line of code there. Step to that and show it to you. That's our last line of code. It just raises the part to our clearance. So if you look at that from the side, you'll see it clears the part. That's it. I mean, how easy is that? And the main thing was we got all these little connecting lines here that connect that at the perimeter. That's the beauty of this whole system that I've just performed before your very eyes. So I mean, how great is that? Now the only thing that I'm a little bit you know, let me rewind this to the top, and we'll start this program, and I'm going to stop it when it gets to the area in question, which is right there. We're cutting a few straight lines over here, alright, and what I really would rather it did is clear right there, okay. I'd be happier if this section over here, see, it's going to cut a bunch of straight lines over here and so forth, and I kind of don't want that. Okay, so here we are in the area of contention. These lines, you may have noticed that I did not eliminate them, and the reason for that was I wanted this thing to scan in a predictable manner, and this is not a very difficult section to fix. There's only a few lines that I want to turn into rapid motions over here, okay? So here's the music from my acoustic days, and we're going to have a camera failure. Okay, so what I basically want to do here is now I'm going to take these lines here, which are feeding on my deck, and I want to raise them and clear the part with them. Okay, I don't have to do this, but I'm going to anyway because I can. So here's how you do it. You just select the line. That'll take you to your line of code over here. So I'm going to double click on this G01 command. I'm going to go edit, replace, and replace that with a G00 rapid motion. Alright. Go to the next line, double click on the code, hit replace. Go to the next line, double click on the code, replace, and so forth. You can see how easy it is to do this with NC Corrector. And that's it. I'm going to leave that last line go. Now all we got to do is insert a couple lines of code before and after that line. So this will give us our clearance. I'll enter in a space. I'll put a G00 and clear it at a Z at 0.1. Now I'll just copy that line and go to my next line, enter in a space before it, paste, go to my next line, enter a space before it, paste, and so forth.
Hey there, Delilah, what's it like in New York City? I'm 1,000 miles away, but girl, tonight you look so pretty, yes you do. Times Square can't shine as bright as you, I swear it's true. Hey there, Delilah, don't you worry about the distance, I'm right there. If you get lonely, give this song another listen, close your eyes. Listen to my voice, it's my disguise, I'm by your side. Oh, it's what you do to me. Oh, it's what you do to me.
Alright, that's it.
Oh, it's what you do to me.
Now you may have noticed it doesn't plunge to my Z where I want it to, okay? So I'm going to go ahead and select on these lines where it plunges down because I want to add a line after that, or before, because I want to add a line before that. Alright, and I'm just going to basically put a Z01, Z minus 0.4. But I also want to give that a feed rate, so I'm going to put an F20 for my plunge. Okay, and I'll copy that line of code. And now I want to go, and for my next line, I just want to put an F60 there. Alright. So I'll go to the next one, right here. Just before that, I'll enter a space and paste, and just after that, I'll enter my feed at 60. So the next one, just before that, enter a space, paste, and on the next line I'll make it a feed 60, and so forth.
Oh, it's what you do to me. What you do to me.
So that's pretty easy. As you can see, just click to that line, enter a space before it, paste my number, and on the following line I'll enter an F60 so that can continue on its merry way. excuse me. NC Corrector is a pretty easy tool to use. For editing code. It's really nice. It's kind of like a text editor, but you're working in 3D. And that's it. We're done. Now I'll show you that, how it plays out. Basically just going to jump up to my clearance, feed down at my plunge rate, and continue on at the feed rate. And that's it. Pretty easy stuff, right? So at this point I just want to press save and save my file, and I'm good to go. The G-code has been edited to my satisfaction. We're looking pretty good here. The rest of the file is good. And we're done. Alright, it's looking all good. So I'll just go File Save, and that's it. That's it. That's all there is to it.